Welcome, my dear friend Svenja. So happy to have you on here. I've wanted to have you on this podcast forever.
Yeah, thanks so much for having me.
I know you're so humble, and so I'll sing all your praises, but I would love to get inside your brain, literally, and find out how you became so interested in neuroscience and the brain.
Yeah, basically, I've been always asking lots of questions, wanted to know why we are the way we are, like even when I was little. Yeah, I mean, when we think about this, the first place to start with it is our brain because what makes us the way we are, how we think, and everything is defined by our or works by our brain. Yeah, I've been reading like when I was in school, I've been reading magazines about um, uh, it was called, it's a German magazine, so it was called Gehirn und Geist, which means brain and the mind. And I've been just really interested in understanding how it works. And so I started to study cognitive science as my first, like my bachelor studies. And it was all about looking at the brain from different perspectives, like neuroscience, cognitive psychology, philosophy, even like artificial intelligence. And I think that's really nice to look at it from different perspectives. And yeah, so I decided to go on with this and studied neural and behavioral sciences and did my PhD in neuropsychology and got deeper into how movement works, perception, and proprioception, actually.
I love that. Well, on that note, how would you describe the difference when we talk about this kind of in general layman terms between the brain and the mind?
That's a good question. Um, yeah, I mean, the brain is really like the anatomical structure. The mind actually is, I feel it's what we are conscious about. Maybe that's a possible way to differentiate it. But then on the other hand, the mind is everything that is made, like what our brain is. The functioning of the brain actually could be described as the mind also.
And what would you say from like early childhood on, the input that we're getting is changing, developing, structuring it in a certain way, but that can always be restructured at any time?
Yes, definitely. So our brain keeps changing all the time. So we say our brain is plastic. And so neuroplasticity is the ability of the brain to change. And actually, it's the normal state of the brain. So the brain always keeps adapting to what we give it. So it's always, it's always changing from childhood on, but also it never stops changing. That's so important to understand.
And are there certain things, and I'm sure there's many, that can either accelerate these changes or conversely make you, even though the brain inherently is plastic, but make you less, like kind of less plastic, kind of more rigid? What are the things that impact that plasticity?
So for the brain to work well, it really needs fuel, which is like oxygen, and which we get from breathing, but also when we exercise or when we laugh, actually, there's a lot of more oxygen getting to the brain. So that's also beneficial. Um, in fact, so the more we learn and keep learning, the more the brain is stimulated to learn, actually, because yeah. So we could also say, by definition, the brain is a bit lazy. So what it knows well or it likes to use the pathways that it knows. And so it definitely needs stimulation to learn. But when we change the demands for our brain, then it will try to adapt to try to just get better at what we try. Sorry, my English
Yeah.
isn't the best.
Oh, no, I know. And she's speaking in her second language, people. This is amazing. You're still more eloquent than most. So on that note, I think this is a great segue into what we're both passionate about, which is posture and movement and all the things that come along with that. Can you explain from your neuroscience background, like why it is important to pay attention to your posture, how your posture affects your brain, how your posture affects the brain's ability to control different movement or send out different signals? Can you talk a little bit about that as it base before we launch into movement?
Sure. Yeah. I mean, posture is also a wide field, I feel. So, of course, we get all the, with the better posture, we get all the benefits on our joints and on the balance of how our muscles work. But I think what also, when we think about the brain and how posture affects the brain, there are lots of different elements too. So, for example, we all probably know that when we sit or stand upright, we can breathe better. So we can breathe more freely. And the breathing itself also signals to the brain. So, of course, I said the brain needs oxygen, but also the way we breathe means something to the brain. So if we breathe in a very shallow way or fast, then this is what is usually associated with stress or fear or something like that. So if we breathe in very full breath and in a relaxed way, then that's a relaxing signal to the brain. That's one point. And then also there are lots of studies showing that the way we hold ourselves and our posture has an effect on our mood and on our thoughts. So the study from Amy Cuddy, which is very popular, where she investigated what effect the posture has. So she had people taking up lots of space in their upper body, maybe like doing the V arms, and just as if you imagine running over or running like
the finish line.
What is it called?
Yeah.
The finish line, exactly.
Yeah.
So, and then compare this to people who have rather like a forward bent posture. And she found that those people with an open and upright posture had actually a hormonal change. So they produced more testosterone and less cortisol. So testosterone, the hormone that's associated with power and like decision making and just
confidence,
and
all the
confidence,
stuff. Yeah.
And cortisol. Sorry, with this is the common stress hormone, and actually the hormonal effect couldn't be replicated by further studies. But what she also showed was that those people have felt more confident, that have been in the power poses, and they were also more they tended to take more risky decisions afterwards than those that were in the low power poses.
Yeah, it's kind of like a contracted sitting at your computer state is really signaling to your brain, whether you're consciously aware of it or not, that you're stressed, that you, and we know that the impact it has on the organs, like you were saying, on your breathing. I'm sure all of that lends itself, but to these actual hormones that, changed by these saliva tests within a few minutes. So I think for anybody that's sitting at your desk while you're reading this or thinking about like how your sitting posture or your standing posture affects you, really try and, again, take up space and just sense for yourself, not only how someone visually sees you, but how it feels inside. Because again, your brain is in a way not able to know any different, but just the signaling from the way that you're holding yourself. It's getting, it changes. So how does that
yeah,
go ahead.
Yeah, I'm sorry. And there are other studies actually showing that when we are in a forward bend posture, we have a much harder time to regulate our mood. So when we're in a negative mood, it's so much harder to really get back to a more positive or neutral mood. And then also when there was a study that gave like where people did a test and then they were told that that they passed the test or that they performed pretty well. And those that were in this forward bend posture in contrast to the ones really upright and taking up space group, they had they were less able to feel the pride and just be happy about the result. So there's lots of evidence just showing how much posture is related to our mood. And also what's really important, I think, is how other people see us. So the posture is not only working internally and giving our own brain the signals, but in the same way, it's been mirrored for other people and how they see us. So it's just really important, what a huge effect it has.
Oh, and yeah. And so we touched a little bit on, you were saying like for the joints and for the mood, but let's talk about for motor firing, how inhabiting a certain posture that is like, let's just categorize it as suboptimal. Again, there's no perfect posture, but there's a spectrum that will be recognized as more optimal. And when you're in a less optimal posture, how is that impacting the signals the brain gives to certain muscles to fire to move you or to support you?
So, yeah, you mean like when we want to get up, or like how we are motivated to move. So probably like when we're in this forward bend posture that we don't feel a lot like moving, but really feel this kind of lazy mood. And then, yeah, like, do you mean that?
Well, that, but also like you were talking about how even though the brain is plastic, it does have a little bias sometimes to whether it's efficiency or just habit to go in a certain pathway. And so if, for instance, your example, like you're sitting in a hunched position and you're not conscious about how to press into the ground and lift up using your hips and holding your spine longer, your go-to might be different, right? You might just be kind of like being less efficient. And then you continue, that's the path you knew. That's the motor, the brain mapping, and so can you talk a little bit about how like why when you change your structural starting point, like via your posture, you are starting to set up a different pathway, perhaps with awareness of what's going to help you move, so it's not going to just be like always overusing your calf muscles or your erector spinae, when your more kind of postural muscles need to come on more.
Okay, yeah, I'm just trying to understand what direction you want to go, because I have so many things coming up now, but I don't know really what to focus on. But
you can riff
I'm
with
just starting. So, our movements are basically, or let's maybe start with how we feel our body, and like, and then how we innervate our muscles. Maybe that's a good point to start. So, actually, we have so our motor, or let's say our muscles have a no, sorry, let's start in another way. So how we feel our body and how we move our body is basically represented in our brain. So we have a motor cortex, and the body parts that we move are represented on our motor cortex, and not in the way how big, like as an example, how big the finger and the hand is, but actually in the way how we are able to control it. So our fingers and our hands, we usually are able to control in a very fine-tuned way. And so the representations of these body parts in our motor cortex are pretty large. While, for example, our feet, usually we're not trained to control very well. So the representations are pretty small. And when we map this, like the whole body in this way, how large the representations are in the motor cortex, we get something like a homunculus. It's called like it's a human that's been represented in the sizes, how the representations are. And so we have a motor cortex and the somatosensory cortex. And the motor cortex is for controlling the movements, and the sensory motor cortex is for feeling the body. And those parts are really tightly coupled. So we usually, we wouldn't have a large sensory representation of the foot and have a very small representation. We wouldn't have a large representation of the foot in the somatosensory cortex. Sorry. So when we feel it, and not have a large representation of the foot in the motor cortex. So it's related. We can't. When we feel something very well, we probably can also move it well. So now trying to come back to your question, this, like how we feel has an effect on how we move. And so the motor cortex signals, the upper motor neurons, they signal a signal down to the spinal cord, where we have the lower motor neurons, and they communicate to the muscles. Basically the tension of the frontal body and the like back body, for example, they are controlled not only via direct signals from the motor cortex, but also via reflexes through the spinal cord, for example, and also by control of the brainstem that really makes us like keep our stance and the tension in our body to control that we are not shifting to one side, for example. Yeah.
Yeah, and when you're talking
when
you're talking tension there, you're talking about kind of like muscle tone, not like stress tension.
Yes,
it's like
of course,
you need some tension so
of
you're
course.
not floppy, right? Right. Yes.
Yeah, thanks for clarifying.
Yeah. So for instance, if somebody was kind of like we see in yoga, like less integrated, so they're maybe they're kind of jutted out in their rib cage, which is pretty common, or anteriorly tilted in the pelvis, and so those back muscles might be kind of on a shortened position. It doesn't mean they're strong, but they're just kind of short, that tension there. And then the front might be a little bit like underwhelmed, not getting enough information. So what is the kind of problem with that when you go into bigger movement patterns and you haven't brought that balance of motor sensory, somatosensory kind of activation into, say, for instance, like the postural muscles that give you so much support?
Yeah, so the control of how we move is actually not only the motor cortex. So I really kind of put this in a very simple way as I explain it right now, but there are lots of parts working together. So let's just say the motor cortex initiates the movement, but then when we plan it, there's the premotor cortex. We have a specific motivation and a goal and decide to move, which is the frontal cortex. And then how we move in space is the parietal cortex. And, then when we fine tune our movements, when we maybe inhibit something, then that's the basal ganglia, just to throw in a few things to give an expression how complicated movement actually is, but not only complicated, but how much of the brain it involves. So it's so important for our brain and affects basically everything. So there's a cerebellum, which is really important for balance, for coordination, but also for learning. And so when we move, we kind of predict what will be the outcome. So when we send a signal from the motor cortex down to the spinal cord, it will actually, the motor cortex will also send a signal to the cerebellum. It's called like an efference copy. So it will send a copy of what movement is planned, and then the cerebellum will calculate what the result will be probably. And so before we even do the movement, the cerebellum might know, is this what we actually want? So is the movement as precise, and is it in the right fine-tuned force and so on? And then it will be able to actually tell the motor cortex to correct this movement before we even do it. So, or before we even finish to do it. So this is how these fine-tuned corrections of movement are possible. And so, there's a lot of going on, and I think it's important to understand that learning actually works through predictions, and that we need to pay attention to recognize if we can adapt anything. So learning always requires observation, and like conscious observation. That's why yoga is so great to learn and to develop a better body image and body representation.
So in yoga, for example, if someone were kind of stepping their leg forward and they feel like, I've run out of space, or what's happened? Can you explain what's happening there? Because everybody will just think of it as being like, oh, my hamstrings are tight. That doesn't allow me to go through, which is the interpretation that we are sensing, that it's our hamstrings that are limiting us. But what is the brain doing at that moment? And obviously it has been signaling that for a while, that somebody all of a sudden just doesn't get a free hamstring opening. So what is it that's happening, and what can people do about that?
So
is that, I know it's like, she's like, honey, the brain is very complicated. I can't process, but as I know, it's hard to decipher that, but maybe in layman's terms, what is kind of happening that is it a reflex that has been, is that kind of overly active that's preventing the movement for a free hamstring kind of extension of the knee, or is there something else going on, or is there a lot going on?
Yeah, I think it's the thing why it's so difficult to answer is because there can be so many factors, and the brain is like how we all have an individual brain. If you look at the brain, it's hard to find an answer that works for everyone. So a possible thing could just be like you say, when you're stretching, right? When you move a leg forward. I didn't like
when you're in down
you
dog and somebody steps their leg forward and they just can't, whether it's their back fascial line is tight, you know what I mean? And they're just like, I can't step it.
Okay, yeah, of course. I mean, there can always be like physical restrictions, as you say, the fascia that's just tight. It could also be like that the motor pattern is not something that we're used to. And so we need to learn how to engage what muscles after each other, and then just to repeat it again and again, and then try to adapt things. And that's the important things. We need to, like, if you repeat things all over again and don't change like anything, probably it's better than not repeating. But we definitely need to pay attention, adapt, and then try again. So and then also when we learn, it's always good to use more than one sense. So for example, we feel our own body, which is like a proprioception from within, the state of our muscles. We can also use our hands to get external feedback from our body, like tactile cues. We can look. So sometimes it's good to just record yourself on video and watch it, so you can see how it really looks, and like sometimes how it feels can be very different from how it looks, and all these things. So it's good to just strengthen the signal from different senses.
Well, I like what you're saying, which I think like, so somebody that is like in down dog and they always tip their foot forward, and the way they've gotten around like that tight fascia or whatever it is, decreased hip mobility, is kind of swinging it out or lifting their hands. essentially what you're saying is you have to retrain a different pathway, which is a different way of doing it, which is new for you, which might mean
Mm-hmm.
press into the floor and maybe just
Mm-hmm.
get the leg up, halfway instead of going into the habitual way, which is going to just give you the same result.
Exactly. And it's actually the brain uses the pathways that it knows. And, the communication of the brain works in networks. So how the neurons are wired. And when we want to change something, we need to really consider that it takes a while. It won't change from like with a snap.
Yes,
And
it's like
so,
when people want to do handstand in 5 days.
yeah.
It's like, well, if you haven't ever done it, there's a lot of
Mm-hmm.
steps along the way, many parts of the brain involved, including your own sense of your amygdala and all that, like sense of fear and but just it's different. So I think it's so important to reiterate, like if
Mm-hmm.
for things to change, it's worthwhile, but you have to bring awareness. So in that
Mm-hmm.
vein, I know we talk a lot about in LYT Yoga this visualization. Can
Mm-hmm.
you talk about why bringing some visualization? For instance, I'll say here is how the mechanics of getting into a handstand. But even if you only lift up a little bit or barely let the ground, start to visualize your body
Mm-hmm.
going there. Why is that an important element of the brain to
Mm-hmm.
visualize something?
Mm-hmm. So there are different factors. One, and I think that's the simplest one, is that we often are like don't believe we can do it, and then when we visualize it, we tell ourselves that we can do it actually, and then believing in ourselves will help us and motivates us. That's one aspect, and I think another very interesting fact is when we look how like when we do a certain action, as I said, the motor cortex will be active, but also when we observe someone do something, there's another kind of network, which is called the mirror neuron network. So when we observe someone do an action, there's the same network active than when we do the movement. I don't know. Hopefully, it was
Yes, no, I know. I've read
understandable.
that
Okay.
where it's like if you are going to do, say, an action, say
Mm-hmm.
we're like doing
Mm-hmm.
a bridge, even
Yeah.
starting to visualize the bridge is stimulating that same action as if you were doing it. Obviously, it isn't sending the
Mm-hmm.
signals, but through that mirror network,
Mm-hmm.
it's starting that, which is, I'm sure, an important process for kind of encoding the track, the beginning of
Mm-hmm.
being able to do it. And so in a way, would
Mm-hmm.
you say it just strengthens the process of motor mapping, whatever it is you're working on?
Exactly. So it was found that when we visualize doing a certain movement, the primary motor cortex is active in the same way as when we want to do it, like as we really plan to do it. The thing that makes us not do it. So the upper motor neurons that are in the motor cortex, they are active, but the lower motor neurons in the spinal cord, they are not active. So if they were active too, we would really do the action. So there are some inhibiting process that makes the upper motor neurons not fire down to the spinal cord. But there was a study actually that focused on mental training. And they made people move they made them do a strength training with their fingers. And actually they made them do the training 5 times for 15 minutes a day and for 12 weeks. So it's a lot of time. But they compared a group of persons that did only the mental training to a group of persons that did the actual training. And they found that 13 to, well, that those people that did the mental training, they improved their strength even for between 13 and 35%. Versus the people that did the actual training, they improved 53% of strength. So basically, I find this really surprising that actually you can even like get half the training effect with mental training than with actual training. But of course, you cannot you can't say, okay, I'm only doing the mental training.
Right. I was going to say, don't use that as an excuse not to.
No,
We
no,
know.
it's not an excuse, but it will just, because you won't train your muscles, right? And you need to do that if you want to really do the training. But I find it's really encouraging to really also do the visualizing aspect of the training, because it can help so much. And if there's a moment where we just can't move, it might make sense to just close the eyes and visualize. It's better than doing nothing.
Absolutely. I think it's so fascinating. I remember reading in some neuroscience magazine, and it was about a basketball player who improved his 3-point shot. I was showing this to my son, and 50% of what he did was absolutely just like spending 15 minutes a day and visualizing it, visualizing it. And I just thought, that's amazing. Like, yeah, you have, because you think of it like, yes, there's motor coordination and all that, but he just essentially amplified it, like rocket shifted his ability to improve dramatically. Well, we could talk for a long time, but I want to head into pain, because I know this is another such a hot topic. You know, people will not move because they're in pain, or they start moving and maybe pain happens and then they are confused. So let's just unpack as best as possible what's an important maybe what's a misconception of pain, and what is an important thing to know about pain that might help people realize that that they don't have to be stopped or preventing movement.
Yeah, I think the biggest misconception is that pain, not brain, that pain arises in the tissue. So actually, the tissue, when it's hurt, it will send a signal to the brain, which like the receptors that signal a threat to the brain, that's how we would say it, they are called nociceptors, but they don't signal the pain itself. The pain is an output signal from the brain, actually. So we can say the brain gets input signals from like interoception from our body tissue, from the muscles, from the organs, and it gets signals from the outside world, like what we see, how what we hear, and also vestibular information, so information about balance from the inner ear. And all of this is integrated, and the brain actually then interprets it. And depending on how relevant the brain thinks this signal or all the signals together are with respect to our own safety, because the brain is all about keeping us safe. And depending on how relevant the brain thinks it is for us, the more probable it will be that it will give us a higher pain. So actually, when we think something is very it's a high risk for our own integrity, then we feel it's very we feel it as much more painful than we think it's a very harmless thing. So a very easy example that I think everyone knows is when children fall, and when they were really young, the first thing they do is they look up to the parents, because they themselves don't know, is it bad or not, and they try to get the confirmation. And when the mother is just ignoring it, or just says, yeah, fine, just keep running,
let me help you up, as opposed to, oh my gosh,
yeah, exactly. And then that's what determines the reaction of the child. And so actually, this is what our brain does within ourselves without us noticing. It always thinks like, okay, is this bad or not? And depending on that, the brain will decide. And with respect to what can we do, or is it good to move or not? Of course, it depends on where it's coming from. Well,
let me give you an example. Say people are sitting around, as many are, at their desk, and they start to feel like this beginning of a little ache. And I think, again, if you have a lot going on, probably the brain filters some of that out and then it gets a little bit louder. But that ache, can you explain, like, what is the brain trying to tell you when you get a little ache in your low back or ache in your sit bones or ache in your neck when you've been sitting for a while? What is that? That's an opinion, but what is it maybe trying to tell us? Or is it just like giving us information maybe we need just to move?
Yeah. Yeah. So actually, pain, just like another signal like fatigue or nausea or like muscle tension, is a signal that the brain wants us to stop what we're doing. So when we keep sitting, that's, yeah. So
We should listen to that smart brain. Yeah.
So it could be, of course, I mean, we never know where it's coming from. It's also, there's an individual factor.
Right.
But in general, it's good to just change what we're doing, and then also to work on trying to make the brain feel more like safer with respect to interpreting the signals that it gets. And so, for example, we never know what adds up to the point where the brain gives us pain. But if we work on our movement control and how we feel our body and pay attention to how we feel and we listen, and then change to or try to get a better coordination of our body, then it will make our brain feel safer. And that's actually probably one of the factors why often movement helps.
Right.
I mean, of course, there are physical effects, where we feel more balanced in our body and the muscles. But also from the brain perspective, that's a huge thing.
I think that's so important because I almost feel like it's like we're paying attention to our friend upstairs, as opposed to ignoring. And there is like when someone pays attention, you just feel more calm. You feel like you're heard. You feel like you're in it together. And I do think, when I know as a physical therapist, when people say, "Oh my gosh, this weekend I did this and I reached over and my back blew out and I don't know what happened." It's just like, and I think to myself, I don't know what happened, but my gut is that there was a lot of buildup until that moment. And there was probably a lot of signals in some way, unless there was like a major structural thing. But it was just that one move was not the thing. It's not like all of a sudden the back doesn't snap. But I think in some ways the brain might have snapped, like, stop, I've been sending you signals to do something different and you haven't. And so now I'm going to send you a really big one. And then that scares, when you get that kind of like sharp pain, again, if it's not structural, but structural similar, it's important to like calm yourself down and realize like and that's like usually the first thing what I tell people is like, you're going to be okay. Like our bodies are really strong, really resilient, but there's something you need to change. And that's what your brain essentially has been asking. So let's examine what it is. And often it is these people are like maybe sitting a lot or just doing one movement a lot repetitively and not getting into these bigger movement patterns that are so good for our joints, so good for our breath, but really also so good for our brain.
Exactly. And that's actually a great thing. Like we can all do just when we feel painful and anything painful or just stress, we can always come back to our breath and then practice like slow and calm breathing. And actually that also gives our brain a signal that we are in a safe state and that it can come down on. And yeah, usually that already gives us a better feeling. Like, for example, when we get this sharp pain, just the first thing is to just calm down and not panic.
Yeah.
And actually, there was a really interesting study I find that was done with yoga practitioners and then a control group. And they found that the yogis did have a higher pain tolerance. So the threshold with how they detected, at what point they detected the pain was the same, but the yogic group was like accepted the pain much longer than the non-yogis. And then later they asked them what it was, and the yoga practitioners said they really paid attention to the pain and then just focused on it and like calmed down their breath. And the non-yogic group, they try to ignore the pain. And that's usually, I mean, what we probably intuitively would do, just trying to ignore it and think about something else. But I find it really interesting that it was found that the other group was much like accepted the pain much longer. And also this study investigated the structural differences, and they found that the yoga practitioners had more gray volume, a higher, or how do you say in English? A higher gray
Concentration
volume,
of gray
matter
matter.
volume.
Mm-hmm.
Sorry.
Mm-hmm.
Yes, actually. So gray matter is the part of the brain that is made up of the cells. Neurons and the glial cells, so supporting cells. And so they had a higher gray matter volume in the insular cortex, which is a part of the cortex that integrates all the signals from within the body, so the interoceptive signals, but also from the motor and sensory motor, somatosensory cortex, and emotions, and so everything. And then the insular cortex is known to be involved in evaluating the pain, like how relevant pain is to us. And so it totally makes sense what they found. I find it really interesting how important interoceptive awareness is, and that's so how beneficial it is to practice paying attention to the inward signals.
Yeah, and I think, like you said at the very beginning, yoga automatically, in some ways, I mean, what it's doing is summoning you to pay attention. It is about going, like, you're not going, it's great to go for a run and all that, but a lot of times you might get like distracted. You know, you're trying to distract yourself a little bit, versus yoga is really asking you to pay attention more moment to moment. And it makes sense that gray matter increased in density. And I think that's an important, I mean, that helps our regulation of our own emotions. It helps memory. All the good stuff that we want. So we need to move, people, and we need to move with paying attention and visualization and all of that wonderful things that you were mentioning today. What are some, leaving us off with a few maybe brain hacks or things to think about when you're practicing movement, whether it's yoga or something else? What are any tips that you would suggest that you might practice yourself?
Yeah, good question. So first of all, I think it's very important to practice regularly and really pay attention to your body and to the signals. I think that's the most important thing, to always come back to it and pause and feel your body, because it's your body. It's very special. It enables you to do so many things, and it's like always being aware that we are never, like, we always have a choice, and our body gives us the possibility to act and to change, and also to always be able to, that we are always able to adapt. And so I think I love to practice really the fine-tuning of the movements, because it will make us feel like we have better control of our body, and we feel more in control of ourselves, and then keep learning. I think that's so important, always to change movement patterns, to work on coordination and transitions, and just also have fun, because that's so important. There's no learning without you enjoying it.
Oh, I love that. Yeah, amen. I just love that. Yeah. And I love what you said about like this autonomy, you know, that we always, that it gives us choice and it gives us agency, and, you know, and this can help in all periods of life, you know, when trials are happening, tribulations or celebrations. It just hones in that sense that we ultimately have that control of ourselves and how we
Hmm.
interact with the world around us. And that's really powerful and empowering. So thank you so much, sweet Svenja. I so appreciate everything you're sharing with us. Where can people find you on your social channels, and maybe mention your book? Even though it's in German, there's German
Hmm.
listeners who might not have heard about it yet.
Yeah, first of all, thanks a lot for having me. So yeah, my book is called The Yoga Effect. So it's in German, as you said. It's all about what we talked. It's the first chapter is more about the neuroscience basics to understand how the nervous system works, how we activate muscles. Then I go deeper into perception and movements, all about our senses, how we integrate them, how we produce movement and fine tune them, how we learn, and the topic of embodiment, so the connection about between the brain and the body. And the third chapter is more about adaptability and posture, how we learn and unlearn, how yoga changes the brain actually, and about mindfulness, breath work, and meditation. And so this book can be found everywhere in German shops, online or offline. You like for the German listeners, it's best to go to my homepage. It's just Svenja Borchers yoga.com, de, genau. And for the English listeners, it's best to just go to my Instagram. It's Svenja Borchers, or also Yoga and the Brain. I have a second page there that really goes more in depth into this topic.
Yes, and we'll put all that in the show notes. Everybody check out Svenja. She's brilliant and humble and a beautiful yoga practitioner, if I say so myself. And a good dear friend. So thank you again for coming on here.
Thank you.
And thank you for listening. And as always, I'm pulling for you.